Hello friends, I welcome you all to my channel. This video is part of the playlist Python Programming, Python Basic Programming, Beginner's Daily Dose, where I try to come up with videos on concepts which are very basic and frequently used in Python programming. And this will help the beginner level programmers, Python programmers or developers to get an insight of how the concepts works behind the scenes in Python. So this is part 3 of the list comprehension topic. I have already uploaded part 1 and part 2. If you have not watched them, then please watch them to get a better idea of the context of this video. In this video, I will end the topic list comprehension by explaining a more complex list comprehension syntax where the first term in the list comprehension expression could also be another list comprehension statement. So, and I will demonstrate that with some examples. Before I get started, I will highly request all of you to please support me by subscribing to my channel. If you are watching my videos and my videos are beneficial to you, then please like them, share them with your friends, and please do not forget to press the bell icon so that you will be notified by my future videos as I will upload this kind of videos on regular basis. So let's get started with this video. Okay, so first let me uh, explain the syntax of the complex list comprehension statement where the expression itself is another list comprehension statement that will look something like this. We have obviously the square brackets, but now the expression will also be another list comprehension where the first term will be an expression, and then we will have a for statement, and after that we can have one or more uh, if clause or for statement. So if or for one or more, zero or more, rather zero or more. uh, this is the expression. This is now the expression of the main list comprehension statement. And of course, after this, we will have for, and again, zero or more for if or clause or for statement. So this is the complex list comprehension statement where the expression, the main list comprehension, the expression of the main list comprehension statement is another list comprehension statement. Now, let's say if I take a example, if I take an example structure, I it won't have any meaning, but let's say we have something like uh, x into x for, let's say we have uh, x into x for uh, x in row. uh, Now row is will be some iterable, and from we are iterating the row iterable, and we are having the each element x, and we are the expression is x into x. This is the expression now uh, of the main list comprehension. So we must have the for. For the for, I am actually the iterable of the for of the main for statement is a 2D list, two-dimensional list or two-dimensional matrix. So I am iterating over each row of the two-dimensional matrix. Let's say, let's say uh, something like 1, comma 2. Uh, this is 1, comma 2, comma 3. Uh, okay. So the iterable in the main in the for statement in the main list comprehension statement, that is the outermost list comprehension statement. The iterable is the two-dimensional matrix of a size 2 by 3. So this is a 2 by 3. Uh, what is this matrix? This matrix is uh, 1, 2, 3, and 1, 2, 3. So now a row is a single row of this two-dimensional matrix. Now, so we are having row. Now, the expression that we are creating, that is the element the the main for the main list comprehension statement. The data expression is again a list comprehension statement. So what? So so this will again be a list. How the elements of this list of this inner list comprehension statements are created: x into x for x in row. So we are now iterating the elements of each single row 1, 2, 3, and we are generating 1 square, 2 square, 3 square. So this essentially should create the matrix 1, 4, 9, 1, 4, 9. Let's check it out, and then I will explain how this structure, how the code behind the structure is actually working. Uh, how this code is actually getting translated to normal Python code. But first, let me check this out. What happened? Okay. Uh, Let me run the Python shell. Okay. Let me first. Okay, fine, I can do it. So x into x for x in row, and we have for row in a matrix where the matrix is 1 comma 3 comma what, oh no, what happened? Okay, for a row in what is happening? For a row in 1 comma 2 comma 3 and 1 comma 2 comma 3. So okay, now over here we are having x into x for x in row. This is what we are trying to understand. So we are having the mat2D matrix 149. The first row is 149 and the second row is 149. Now let's try to understand how this uh, code is gets translated to the usual normal code. So this code, to give you a better idea of how this is actually working, what is happening is, for sure, we are having the main list that will be created, initialized to empty. Then we will have the for, that is for row in this iterable, which is a 2D matrix. Okay. Now inside the for, the the innermost the inner list comprehension will work. Now the inner list comprehension will obviously create another list. So for that, we will have another temporary list, let's say this. And now we are writing the code, translating the code for the inner list comprehension. So we will have for so this row, the inner list comprehension row, this variable will be in scope. This row is the same as the row of the for statement of the outer list comprehension. So for for x in row, what we are doing, we are appending x dot x to L2 x dot x. So L2, and finally uh, after the inner after the data, after the L2 is created, that is after the inner list comprehension finishes, we must append the L2 to L1, because L2 is actually the data, the expression that is being created as the expression of the outermost list comprehension. So this thing, and then finally we return L. I hope it's clear. So this is how we can use inner list comprehension statement as the data expression of a main list comprehension statement. Now let's try a few examples. So let's say, so basically using an inner list comprehension statement, we can create two-dimensional matrix. Let's say we want to create a two-dimensional matrix. Let's say we want to create two-dimensional matrix. Let's say uh, matrix of size, create two-dimensional matrix of size, let's say 5 by 4, where each element is some number, let's say 0. So basically we are trying to create something, a matrix 5 by 4, something like this, 0 1 2 3 4, 0 2 3 4, 0 1 2 3 4, 0 1 2 3 4, 1. There will be 5 rows, 1 2 3 4. This matrix we are trying to create using list comprehension, where the also using inner list comprehension. So uh, first of all, uh, see, uh, when we are trying to create this 2D matrix, the rows, when we are trying to create the rows, creating the rows is actually uh, a row. When we are creating a row, that row is actually the data expression that is being created for the outermost list comprehension statement. And when this row is being created, for this row, for a particular row, all the elements that are being created, that those elements are being created by the inner list comprehension statement. So the code list comprehension statement will look like this. So first, this list comprehension will actually generate uh, the the a particular row. This list comprehension, the inner list comprehension, will generate a particular row. So we will have all the elements are 0. So 0 for what will be the iterable. Now, how many how what is the 2D matrix is having 4 columns. So definitely it will have iterate 4 times. So we will have, now how come, uh, okay, yeah, 4 times. So i for I in range 5, to loop 4 times we have to give 5 as a parameter to range. Now 0 for I in range. This is creating a list of 5 zeros. So which is basically will be each single row of the 2D matrix. Now then we will have how many rows need to be created. J, for that iteration we how many columns, how many rows are there? 5, so 6. This is the list comprehension statement for generating the 5 by 4 2D matrix where each element is 0. It is very hot, so I am wiping my head every now and then. Sorry for that. Okay, let's try to see if this code works or not. So the inner we have 0 for I in range. This is 5. So the inner list comprehension ends, and then we have for j in range 6. Let's see. Mhm. So how many? Uh, how many this list? How many elements are there in this list? 1, 2, 3, 4, 5, and 6. So we have 6 elements, and each element, which is basically a row of the 2D matrix, we have 1, 2, 3, 4, 5. Why 5? It must have 6. How many rows are there? Rows is number of rows is 5, and number of columns is 4. So actually, the diagram is also wrong, and my statement is also wrong. The matrix will be this will be the matrix, and also for j in range 6, it should iterate over the number of rows. So definitely this will be 5. So range 5 means it's a sequence, it's 0, 1, 2, 3, 4. And this should be 4. This should be 4. Okay. So if I rerun this is 5 and this is 4, then I will get a 2D matrix of 5 rows and 4 columns where all the elements are 0. So this was a very basic demonstration how we can use uh, inner list comprehension statement in an outer list comprehension statement. So now you can also use if clause inside the inner list comprehension statement as well as in the outer list comprehension statement. Those you can do as per your requirement. I've already explained how the if clause and the for clause, subsequent for clause after the first main for clause works. So now, okay, I've already explained. Okay, so let's try to modify this statement and add some if clause and do a little bit of and try to create a little different matrix of the same size 5 by 4, and let's say all the diagonal elements will be 1. So what will be the list comprehension statement? Obviously we have to use if clause. Okay, so what will be? So all the diagonal elements means that the I and j will be same. When I and j are same, that means it's a diagonal element, and for that we will add 1 instead of 0. We will add 1. Otherwise, we will add 0. So create 2D matrix of size 5 by 4 where each where each element is 0 except the diagonal elements which are 1. So basically we are trying to create uh, 1, 2, 3, 0, 1. We are trying to create this matrix. Not this one. Uh, this matrix we are trying to create. So basically, we will just have to add some if clause in the uh, from the first example. Okay, let's try it. What will be the least comprehension statement? It should be easy. Uh, so okay, now uh, hmm, hmm, hmm. I okay. This expression, I'm just writing it at expression E. I have to calculate that, find that. So for I in range, this is fine. I have to add some if. Hmm, if can be if clause. So in okay, there will be some kind of if, and this will remain the same range 5. Now inside the inner list comprehension statement, E will be 0 when I and J are same, and E will be 1 when I and J are same, and E will be 0 when I not equals to J. How to specify that with the if clause? Uh, if because if clause with the if clause we actually do filtering, but how do we generate the data expression based on if clause? Mm, I am not sure of that. Mm, what we can do is we can do it other way around. We can omit this if, and we can this this e we have to generate e using some if else condition. So let me see if I can do that. Uh, no, there is no space. Sorry. So this E, the code for this E should actually be like what will be I equals to J. Can we write this? Can we write this? So this will I equals to J will evaluate to 1 if I and j are same. Otherwise, it will be valued to 0. Well, this is other this code. If even if it works, it's a little different way of doing. I was thinking to use if clause to do it. Anyway, let's check it out. If what uh, is the output? If I do simply if I equals to j, what it gives? It should give all the diagonal elements. Oh, sorry. No. So it will be true. So I equals to j will always be evaluated to true false. But we need 0 and 1. We need 0 and 1. So we need 0 and 1. So I and j are same. Okay. I and j are same. There is a way like let me just check few things. 0 if 2 equals to 3, else 1, 0 else 1. If 2 equals to 3, it is not, so else is working. Okay, so maybe we can do for the data expression 1 if and else 0. Okay, so this part is actually the expression part of the inner list comprehension statement. This should give either 0 when I and j are unequal and 1 if I and j are equal. Now we should have the 2D matrix where the diagonal elements are 1, but we did not get 1 for the last row. How many rows are we getting? 1, 2, 3, 4, 5. 5 rows, and in each rows we are getting here. So why the last 1, 2, 3, 4, 1, 2, 3, 4. One, two, three, four. In my diagram on the right hand side, I have mentioned that this 2D matrix is wrong. There is only 4 rows. Actually, this should be there should be one more row. Anyway, so we are iterating the for statement in the inner list comprehension is iterating how many times? 4 times. 0, 1, 2, 3. 4 times. Meaning it will create the row of 4 elements. Yeah, that is fine. And so 1, 2, 3, 4, 5, and 1, 2, yeah, it is not working. I mean, okay, it is not working because the matrix is not a square matrix. So it is not a square matrix. That is the reason we are having all zeros as the in the last row. If it had been a square matrix, let's say if it would have been 5 by 5, I hope we will get a good, yeah, now it's fine. Okay. Now, I hope you're getting a clear idea how uh, things are working when we use an inner list comprehension as the expression of the main list comprehension statement. Now, Let's say the last example that I would like to discuss is that we would like to transpose we would like to transpose a given matrix uh, using list comprehension. Obviously, that list comprehension will have also inner list comprehension statement. So let's say A is something like uh, 1, 2, 3, uh, 4, 5, 6, and 7, 8, 9. So this is a 3 by 3 square matrix. This is a 3 by 3 square matrix. Basically, the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This matrix. We would like to transpose, create transpose using list comprehension. Now, uh, okay. So how will the matrix A transpose look like? If this is A, so A3 will be something like 1, 4, 7, 1, 4, 7, 2, 5, 8, 3, 6, 9. I hope I'm right. 1, 4, 7, 2, 5, 8, 3, 6, 9. Okay. So before trying to write the statement using list comprehension, let's try to understand the logic. So obviously the A transpose will also be a 3 by 3 matrix. Now, how come how come the rows are being created in A transpose? 147. This 147 is coming from the first column, values of the first column of the matrix A, 147. 258, the second row of A transpose, 257 is basically the elements of the second row of A transpose is basically the elements vertically down of the second column of A. Similarly, the third row. So, uh, mm, okay. Uh, uh, Now, this is a simple example because the matrix is 3 by 3. It could have been of any dimension. So it could have been any dimension. Mm, So first, how do we create the how do we create the row uh, each row of the A transpose? Definitely, that row each row of the A transpose will be created using the inner list comprehension statement. Okay, and how do we iterate the main list comprehension, the outermost list comprehension? What we will iterate? We will iterate. So how many rows will be created in A transpose? How many rows? The number of columns in A. You see, after transpose, the number of columns, the number of rows in A transpose is equal to the number of columns in A. Okay, let's try to write the uh, list comprehension statement. So definitely we will have the main list comprehension and then the inner list comprehension. This inner comprehension will actually create the row of the A transpose, each row of the A transpose. Now, let's iterate the main for statement. That is a for statement of the outermost inner, the main list comprehension statement. Let's iterate over the number of columns in A. So we have for j in range of, what is the number of columns from A we get is A 0. Hmm. Things are getting clumsy. Hmm. Okay. Okay. So for j in range A0, what is A0? A0 is the A0 is the A0 is the first row of the matrix A. So we must have length of A0. Hmm. I have to increase the width. Hmm. That is not help. Okay. Let me uh, let me move it down. Right. So okay. Now so this one will be actually length of A0. Length A0 is the number of columns in A. Okay. Uh, this is the main list comprehension. So we are iterating over the number of columns in A. Fine. Now for from each column index of A, we have to access all the vertical elements down the row in A. That is, we have to, if for so for a particular column index J, we have to somehow create a list from the elements A from the column A J from the column jth column. So the elements will be A0J, A1J, A2J, like that. And so how do okay, uh, now what if, so basically from a particular column index, we have to then iterate over the number of rows in the matrix A. So for I in range range length of A is basically the number of rows. Now, so we are iterating uh, for a particular j. So we are at jth column in A, and from that jth column, we need to access all the elements of that column vertically down all the rows, and those elements will create the row for the A transpose. So for I in J, what if I do here? Uh, what if I do here? What do I need? Uh, I and J. So basically, I am at a particular column. Let's say this column, this column. This is A. I'm at this is column J. So and I have all the values down. So A, B, C, D, E, depending on the number of rows of A. So I have to create the list. This inner list comprehension is trying to create this list A, B, C, D, E. That is what we have to do, because then this list will become the row of the final 2D matrix. Now A, B, C, D, E. If you do A, I, J, is it right? Uh, I'm not sure. I have to check that. But okay, let's try the statement, but it will not work because we have to first declare the A. Okay, so let's declare the A matrix as we have uh, so 1, 2, 3, 1, 2, 3, then 4, 5, 6, and then 7, 8, 9. No, this is the 2D matrix we are trying to transpose. Okay, so now if we execute the list comprehension statement that we just wrote, let's see if it works or not. So we are trying to, this is the inner list comprehension, and the outermost for, we are iterating over the column index in range length of A 0, this and this. Okay, now the inner will be A, I, uh, J, for I in range length A. So let's see if this works or not. I'm not sure at all. What happened? Okay, what did we get? 147,258,369. Perfect. So it worked. Okay, fine. So this was the main example that I wanted to implement using the complex list comprehension statement, where the expression itself is another inner list comprehension statement. So that was all for this video. I hope these 3 videos will give you a good idea of how list comprehension works in Python. If you have any doubt or any question, please do let me know in the comment section. I will be glad to help you out within my capacity and limit. Thanks for watching, and until the next video, take care and bye.